Kia ora koutou. This is the second part of the video I'm doing on this practice task with St Mark's School getting some new sunshades. And I nearly got finished the whole thing, but we're up to the bit where we're finding the lost area from the fact that the shade sails are actually curved bits of fabric and not just triangles. So where I got to is that I'd found this lost area here, and I'd found this curvy length here just about. I hadn't actually finished that calculation. Now we need to do the same thing for these other two here, but as I said earlier, that you can do those two just using similar triangles. I'm going to assume, that is the most terrible picture, I'm going to assume that you don't spot that they're similar triangles, and I'm just going to do it the slow way. So earlier on, we found that the angle at the center of the circle was 31.9 degrees or 0.5566 radians. From there, we could very easily get the arc length. So that's just the radius, which was 7.644, times the arc length, and that gave us 4.25 meters. And the lost area was the area of the segment that came from it being curved and not a straight line. And that worked out to be 0.8267 meters squared. So I suspect there are not many people still watching, because really all I've got to do now is repeat the same thing for the other two sides. So let's just hop back up to here and see what those other two sides are going to involve. Well, I have to find 1.82z and 1.82x, and those two numbers there are my original triangle ones. Okay, so let's just work through that now. So for triangle 2, we have 1.82 times 5.3 gave me 9.646 meters, and theta 2 came from the cosine rule again. And as you're doing this, you should be getting a feel that everything is just somehow being times through, so the angles are not changing, right? The lengths are all in proportion to each other, so the angle at the center of the circle hasn't changed. Now that again gives me 0.84905. So that's not quite right. That's cosine of theta 2, sorry. And that means that theta is the angle whose cosine is 0.84095. So theta is equal to 0.5566 again. And then by similar triangles, theta 3 is also equal to 0.5566. So if I am going to use similar triangles, I really want to have a little bit of reasoning for that. So what I would do if I were using similar triangles is that I would pop in 3 little triangles. So let's just quickly draw in 3 triangles. And here's the third one. Because I think what's really important when you're doing a task like this is that you do try to communicate your reasoning, that you don't just suddenly go, hey, the angles must all be the same. But it goes like this. This side is x, and this side is 1.82x, and so is this one. And if you write it out like this, you can see that all the lengths are in proportion to each other. So for example, y over x is equal to, let's try again, 1.82x over x here is the same ratio by definition as this one in here. And that's the same as this ratio here. In each case, they're equal to 1.82. So triangle angles must all be identical. Okay, so this, and this must be the same. This one, and this one must be the same. And in fact, because they're isosceles, these two are going to be equal. Anyway, now I'm getting sidetracked, but this is kind of a cool part of the problem, I think. So what we have to do now is we have to figure out, very boringly, what are the arc lengths and what are the segment areas. So r theta is equal to, what do we get here? 1.82 times 6.233 is equal to 11.344 meters, and that's for triangle 3. And we get the arc length for triangle 2. R theta works out to be what? I'm just trying to see it on my bits of paper. Okay, so we get 1.82 times 5.3 was 9.646 meters. And from up above, we had the first arc length here was 4.25. So now we're in a position where we can get the perimeter. Right, so the perimeter of those three will just be what those numbers were added up. So 9.646 plus 4.25 plus 11.344, giving us, I think I got 15.94 meters for that one. Now what about the lost area? So the lost area on triangle 2 is equal to a half r squared theta minus sine theta again. So it's a half times the 9.646 squared times this. And you'll see, of course, this factor is exactly the same as the one we had earlier. So that's that second lost area, and the third lost area is a half r squared times this, which works out to be, I'm putting all of the working in on purpose, just so that you can see that it actually doesn't take that long. Whoops. Oh, and the printer is randomly printing something out. What have we got here? So this last one is the biggest of the lost areas. So let's just underline those or put a box around them. So we've got 3 lost areas. So the total lost area is those 3 added together. I think it's fine to round at this point. And 0.83 meters squared. So I got, what do we get there? I actually got 3.96 in my calculations before. If you add those up like that, you'll get 3.97. Okay, but that amount of rounding error is fine. So there we go. Total lost area is that, and we've done the perimeter. So that's the whole task done. So please leave me a message or send me an email if you've got any questions on that one.